Hi, my name is Eric Spengler, and we're going to talk a little bit about teaching route summarization. Now, route summarization is a little bit different than subnetting. Within subnetting, from a technical standpoint, we take a network prefix and we break it down into smaller networks. Well, the nice thing about teaching route summarization is if we teach it after we teach subnetting, we're able to talk to the students about not breaking it down this time, but we're able to talk to the students about building those group of network prefixes up into a single prefix. And there's some big advantages for students to understand why we do this. And from a routing perspective, one of the biggest advantages is we're able to optimize the resources that we have on our network. Instead of having a router with a routing table with several hundred or thousands of routing statements, by using route summarization, we're able to reduce the size of that routing table down to possibly only a few statements, thereby reducing the CPU we use on our routers and also reducing the memory that's required to do the route processing. So our whole network possibly can be sped up by understanding the best practice of route summarization. So what we're going to talk about today is a practice that I use when I try to get the students to understand what the route summarization process is. So let's take a look at what we have here. First of all, route summarization is something that's practiced in all routing protocols. So if we're using RIP or EIGRP or OSPF or ISIS or BJP, all protocols that are generally taught sometime within the Academy program, each of these protocols supports the ability to take multiple networks, consolidate them into a single prefix, and then advertise that prefix independently of the individual routing updates. So we can optimize and again reduce the size of our routing table. So here's a more visual example that sometimes I draw up ad hoc with the students. And I try to say, here's a group of networks, and they all have some reference to the 192.168.1 prefix. But you'll notice the CIDR notation, which is the size of the subnet, and the ID of the network, they're all different. In some cases, I just made a little bit of note that they could be whatever. So we take those and we put those through that consolidation process or that summarization process, and lo and behold, at the end, we end up with a network prefix. This network prefix, 192.168.1.0/24, represents all of these networks that we undoubtedly created within the subnetting process. But again, instead of breaking it down, we're taking our broken down group of networks and pushing them in so that anytime a router looks at this prefix, that prefix represents all these network prefixes that are under. So how do we represent that in another way to get students to understand? Okay, well, I have two approaches that I use. One approach is to keep it simple, meaning instead of going with CIDR notation with a .4/30 or a .32/27, I break it down into a nice Class A network, type network, and look at the pieces within that. And I apply that to network design. So I said, first, if we want to represent this entire picture, let's break it down and look at how the pieces could be broken down. Well, first, a practice that I use, and I've been using in network design for the past 20 years, is to identify my locations and my networks independently because, of course, in a private network, I have a lot of network space to deal with. So the location in this case is identified specifically, and I reserve this entire part for the location. Within the networks, because each location can be, again, broken down from that subnetting process into multiple networks, I identify this piece as covering those networks which are identifiable within that location. So if I look at 10.location.VLAN, I can now represent a fairly large network, and in this case, this network could be 700-800 networks in representation. But I broke it down very easily to say 10.location 1 or 2 or 3 .VLAN or network ID, which is 0 through 255. So I have a possibility to have 255 networks here, 255 here, 255 here, and of course, my location growth can be from 0 to 255, so I can have a fairly large group of networks. But when I start to move into the thousands and thousands of networks as our networks expand, again, our routing tables can increase. So the practice that I use, a simple practice, is I use a picture sort of group of umbrellas. And I talk to the students very simply about, if I have an umbrella, let's look at the top and the largest umbrella prefix as 10,000. And again, I can represent any prefix within that, but that's our largest prefix. And as I start to draw smaller umbrellas, I start to see that these prefixes change as the subnetting size change. And we go down and down and down. And I break that down, and then at the end, I typically will tell the students again, let's keep in mind that subnetting we're breaking down, and in route summarization, we are building up. Now we can take these individual routes, we can place them on our routers, 1, 2, or 3, and if, let's say, for example, router 1 wants to get to any of the networks in location 3 or any of the network in location 2, these individual networks can be represented with one statement instead of several hundred within router 1. And in this case, router 1 would have a prefix notation in route summarization of 10.2, and that would represent all networks here. Router 1 would have a notation for location 3 as 10.3, and that would represent all networks down here. Therefore, instead of having 500 networks identified in router 1, we only have 2 prefixes, and that's how router 1 can make its decisions. Thank you.